Hi, welcome to engiNERDing. Today we're going to be doing an example where we will be learning some basic surveying skills of joins and polars as well as orientation of direction. Alright, so we look at the information that's been given to us. Firstly, we can see the coordinates of C and D were given to us, as well as the distances of C to A and D to A. Then we also got given observations at station D. These are non-orientated directions, which mean they are not final directions from D to C and D to A. So this is very important. We need to correct this if we actually want to use this in any way. And then we have an orientated direction of AC. So we'll start with our first question where it says calculate the join CD. So we'll start our calculation by first putting our C and our D coordinates in this arrangement. So we'll say our C coordinates first, D coordinates second. Then what to do is we'll subtract the C coordinates from the D coordinates. In other words, we'll say the Y coordinate of D minus the Y coordinate of C will give us our delta Y value. Then our x coordinate of D minus our x coordinate of C will give us our delta x value. So now we have a delta x and delta y value, which we will use to calculate our distance and direction. So the way we do that is we'll use these two formulas. So firstly, we'll use distance or calculate distance. We'll use this formula, which is a rearranged formula of Pythagoras. So we say our delta y, which we calculated, squared, plus our delta x, which we calculated, squared, and then we'll square root that answer to get a distance of 8,955.822 meters. Then our direction is slightly more complicated because first we would use arctan of delta y over delta x, and this would give us a value of 10 degrees 43 minutes 38.51 seconds. However, due to the quadrant that we are in, we'll have to check our x and our y to see what we should do with the alpha value. Now the alpha value is the value we get from calculating using this formula. So we'll first check our delta x, which is this value over here, and if it is negative, then we have to say our alpha value plus 180 degrees, which in this case is the scenario we have. So we'll say the 10 degrees plus the 180 degrees, and this will give us our 190 degrees 43 minutes and 38.51 seconds. However, if it was positive, we would go and check y, which in that case, if it was negative, we would add 360 or leave it as it is if it was positive. Alright, so once we've calculated this, we have to test it using a polar. So a join calculates distance and direction, while polar calculates coordinates using distance and direction. So they are basically the opposites of each other, so they are good tests to test if we've done the calculation correctly. So we take the distance and direction, which we've calculated over here, we'll put it into this table, but once again our C coordinates are the first coordinates, same as this scenario, except that we will use a delta y and a delta x value that we calculate. Now the way we calculate this is we'll use these two formulas. Delta y's formula is distance times sine of direction, so it'll be this distance times the sine of this direction, and we'll get a delta y value. Then we do the same with the delta x, except we use cos instead of sine. So we say our distance times the cos of this direction, and we get a delta x value. Then what we'll do is we'll say our coordinate for y, for the C, we'll say this plus our delta y, and we'll get a D coordinate. And we also take our x coordinate for C, plus our delta x, and we'll get a x coordinate for D as well. Now if these two values, our delta y and our delta x, are very similar to the original ones we had, we can see that we've done our calculation correctly. But then the final check will be if our D coordinates are the same as the original D coordinates that were given to us. Decimals will change because of values are not saving some values, but if these coordinates are very similar or exactly the same to these original coordinates, then we know we've done our calculations correctly. So this is a join and polar calculation. Our next question is to orientate the observation at D to obtain the orientated direction dA. Alright, so at D we have D to C and D to A. They want us to orientate dA. So they want us to take D to A, so there's 181 degrees, 21 minutes and 10 seconds. And should be orientated so that it is correct. Now, from the information we have already calculated. If we go back to our example, alright, so now our second question will be orientate the observation at D to obtain the orientated direction dA. Alright, so our observation at D, we have D to C and D to A. So we want to take this 181, 20, 10 and we want to orientate it that it's correct. Now to do this we need to find a correction, and the way we do that correction is we will relate it to our other point, which in this case is C. So we want D to C, an orientated version of that, so we can work out our correction. Alright, so looking from the information we have AC, which is our orientated direction. That will not help us. However, we go back to our previous calculation, we'll see that we have a direction for C and D. So what we do is we'll use C and D to orientate our DC and DA. So we have CD, which we just calculated. However, this CD is not correct because we need DC, D to C. So what we'll do is we have to say our calculated value minus 180 degrees to get DC. The reason we do this is because 180 degrees is the opposite direction. In other words, instead of being from C to D, we now have from D to C, which is why we get 10 degrees, 43 minutes, 38.51 seconds. From there, we'll calculate our correction. So we take XDC, our join direction, which is orientated, because this was orientated and we just use the opposite to it over here. We take our observed direction, which was given to us at the setup, and we calculate our correction. Now this correction is quite a massive correction, means the surveyor or someone on site made a massive error. However, we still need to use this correction. So to calculate dA, we have to take our observed direction, which was given to us, the set reading at D to A, and we have to apply our correction, which we just calculated, and this correction plus the observed direction will give us our coordinates or our direction for dA, which is our orientated direction. However, this is a negative value, so we'll add 360 to it to get our positive value. That doesn't actually change the angle, it just changes it from from negative to a positive reading. And that's how we orientate a direction. We basically calculate our correction and use that correction on our observed direction to get our orientated direction. Then our final question, calculate the polar dA, also calculate the polar CA. The two calculated values for the coordinates of A should be the same. So in the end, we must check our A coordinates. So they're polars. Polars require distances and direction. So looking at the information given to us, we have our dA, which we just orientated. We also have our distance for dA. For CA we have a distance as well, and we also have AC, which is an orientated direction. So what we do with this AC is we'll add 180 degrees, so it'll be CA. So we'll say this 30 degrees, 12 minutes and 35 seconds, plus 180, and we'll get 210, 12, 35. Alright, so now we have our distances which are given to us, and our directions that were calculated. So in the tables, once again, you put your first coordinate, in this case D and C, then you calculate your delta Y and delta X using distance times the sine of direction or the cos of the direction. We'll get our delta Y, delta X, our delta Y, and our delta X. So it'll be this distance and that direction for this table, this distance and this direction for this table. From there we simply say our coordinates plus the delta Y and delta X values to give us our coordinates for A. We do the same over here, so we'll say our Y coordinate for C plus delta Y gives us A Y coordinate, and then C's X coordinate plus delta X gives us our X coordinate for A. So these values should be very similar because they're coordinates for A. You'll see they are similar, just the decimal values will differ a little bit due to calculation errors, or let's say that the full saved values were not used, but that is pretty much correct. Now we can say that's correct, but we still need to test it with joins. You always test a join or polar with join and a join with a polar. So what we'll do is we'll calculate our delta Y and delta X values for DA and for CA by saying the Y coordinate minus the first Y coordinate, same this, the A's Y coordinate minus the C's Y coordinate to get our delta Y's, same with the delta X's, bottom coordinate minus the top coordinate. And then we use this by using these two formulas we used earlier. We will put in our delta Y and delta X values to calculate our two distances, and we also use arctan to calculate our directions.